In this session we are going to discuss a problem on frictional force, and this problem is the problem that a block is placed against a wall. Go through the problem. This one is the block which is placed against a vertical wall by the application of 12 Newton force, right? This block has the weight of 5 Newton, right? The coefficient of static friction is 0.6 and the coefficient of kinetic friction equals to 0.55, right? We have to find the magnitude of the frictional force exerted by the wall on the block, and we have to find the acceleration of the block, right? In this problem, we do not know about the motion of this block against this wall. That means the block is not moving along the wall, or the block can move along the wall. First of all, assume that the block is at rest, but the block has the tendency of motion vertical downward due to the weight mg which is acting vertical downward, right? The frictional force acting by this wall on the block will be the static frictional force, and this static frictional force will act vertical upward. If our assumption is true, then this static friction force must be less than or equal to limiting static friction force. First of all, assume that the block is at rest on the wall, i.e. block is not sliding along the wall, right? But the block has the tendency of relative motion vertical downward, right? Hence the frictional force acting on this block will have the static friction force, and this force will act vertical upward, right? If this force will be less than or equal to limiting static friction force, then our assumption is true. Otherwise, our assumption will be wrong. Now, first of all, check that whether our assumption is true or not. We have to draw the free body diagram of this block, right? There are different forces which is acted by the surrounding on this block. One is the applied force of 12 Newton, due to which the block will be placed against the wall, right? Next one is the weight mg which is acted by the earth, and this weight mg will be the 5 Newton, right? Next force is the normal reaction acted by the vertical wall, and the next one is the, which is most important, is the frictional force, and this friction force is acting vertical upward because this block has the tendency of relative motion according to our assumption downward due to the weight 5 Newton. First of all, we have to find the value of friction force, this friction force. If this friction force will be less than or equal to limiting static friction force, then our assumption will be true. We are going to apply the Newton's second law along the vertical direction, right? Net force along the vertical direction, that means along the y-axis, is given by 5 minus f. That will be equal to 0 because we have assumed that the block is at rest. Hence, according to our assumption, the static friction will have the value of 5 Newton, right? Now, apply the Newton's second law along the x-axis, right? According to the Newton's second law along the x-axis, r minus 12, that will be equal to 0 because the block does not have any acceleration along the x-axis due to the presence of wall, right? Hence r minus 12 equal to 0. Hence the normal reaction will be equal to 12 Newton. Apply Newton's second law along the x-axis that we have discussed. 12 minus r will be equal to 0. You can write down also r minus 12 equal to 0, and hence r will be equal to 12 Newton. Applying the Newton's second law along the y-axis, and along the y-axis net force will be equal to 5 minus f, that will be equal to 0. 5 minus f, that will be equal to 0 because the block do not have any motion along the wall. According to our assumption, static friction force will have the 5 Newton, right? Now, first of all, find the value of limiting static friction force. Now, the value of limiting static friction force is given by mu s into r. The coefficient of static friction is 0.6 and the normal reaction will be equal to 12 Newton. Hence, the limiting static friction force is 7.2 Newton. As the limiting static friction force is 7.2 Newton and the frictional force and the static friction force is 5 Newton. Hence, our assumption is true because this static friction force is less than 7.2 Newton. Static friction force acting on the block is 5 Newton and as the block is not moving along the wall, that's why the extension of the block is 0, right?